Bauplan is a simple serverless data platform designed specifically for Python developers working with S3 object storage. We provide serverless Python functions over tables in S3 and a simple API to create branches and versions of your data so you can easily work in the cloud on real data without interfering with your production environment. Now, I'll show you how you can use Bauplan to build data pipelines for analytics, machine learning, and AI applications, all at scale in pure Python without having to know anything about big data and cloud infrastructure. Now, let's start by looking at the data. With Bauplan, you can explore your S3 data directly as tables in a data catalog like this. Like these are all tables that are now in our S3 bucket. Now we're going to take two of these tables and we're going to join them and we're going to create a new table that we're going to write back into S3. This is how you do it in Bauplan. You simply write a simple Python function with two inputs, the tables that we want to join. You can specify the columns and the filters that you want to apply directly in your code. We're going to take a quarter of data from the taxi dataset of the city of New York. And we're going to specify in a decorator what are the dependencies that we need to run this function, in this case, DuckDB. And then we're off the races and we can just run this function in the cloud. The system now automatically creates a container, gets the data from S3, runs the code, and writes a new table back in S3. There's no pulling data to my local computer. There's no need to use a data sample. We can just run this function against real data in our data lake in a few seconds. And the system streams back in real time. What we see here in the terminal are the print statements that are here in our code. We're printing the size of the table, which is more than 3 gigabytes. In less than 30 seconds, we have a new table in S3 that is just here ready to be explored. And we can even run a query over it and see in real time the data that we just created and written and wrote into our data lake. This system is very flexible. We can change dependencies and iterate in the cloud very quickly. For instance, let's say that we want to do something more articulated here and add pandas as a dependency. I can just add pandas in my decorator, import it, and we're going to do something simple here. We're going to add just like a print statement where we take our table, we convert it into a pandas data frame, and then we're going to just like print the first rows of the data frame so we can run it again and see this preview of data directly in the terminal. What the system will do now is just create the container back again, mounting the new dependencies, and it's going to take just like a few seconds because the runtime is so fast at creating containers and running S3 scans and moving data around. And streaming back in real time, we can now immediately check our change in code right here in the terminal where it is supposed to be. As you can see, the feeling is that we're developing locally, but actually we're using all the flexibility and the performances of a cloud runtime. Now, this is all good, but we want to do something that is a little bit more articulated than this. Instead of just running a single function, what we want to do is run a pipeline. So we're going to take this function that I prepared and just like paste it in our script and then run again. What this is going to do is run these two functions in a sequence, and this is what it looks like to have a pipeline in Bauplan. It's just a bunch of Python functions that are chained together. This function right here, for instance, goes as an input into the next one. And now the two functions are executed as fully containerized and independent functions that pass data onto each other in a DAG. Now, the second function that I prepared here does a couple of interesting things. It does some filtering and aggregations using pandas, but more interestingly, it uses OpenAI, that is an external API, to do some data enrichment. In this particular case, we're going to ask GPT-4 to prepare a report in plain English about the data that we have, and we're going to save the output of the LLM back into a structured table in our data lake. So here we are, and we can see right here that we can get the new table that we just created where we have a quarterly report column that contains the output of our LLM that is now stored in our data lake as a structured output. And we can use it, query it, manage it like we used to do and with all other tables and all other structured outputs. Now, one thing that I mentioned in the beginning are data branches. As a matter of fact, right now I'm working with a real data in my data lake, but I'm not writing in a production data lake. I am actually in a branch. A branch is a namespace sandbox where I can work with my real data without messing up the production environment. So if I wanted to bring the new tables that I just created by running the pipeline in the production data lake, we'll have to merge this branch. So to do that, it looks a lot like what you would do with Git. We're gonna just like check out to main, and then we're gonna do Bauplan branch merge. And we're gonna call branch that we want to merge. At this point, we can expect the table to find the tables that we just created directly in our production data lake, which is exactly what we found right here. So that's done. This is the power of Bauplan. You can, without effort, going from a bunch of files in an S3 bucket to an end-to-end pipeline in production with just a few Python functions and a handful of API calls. No more hustling with your local scripts. Work directly in the cloud over S3 without any infrastructure. No Spark, no Kubernetes, no Parquet files, no nonsense. Just simple, testable Python functions and tables. All you need is an S3 bucket and an internet connection. Thank you very much.